we are given this function f equal to t for t between 0 and 2 and equal to 1 for t between 2 and 3. We need to find the Fourier sine and cosine series of f. So recall that we have these two formulas for Fourier cosine and Fourier sine series. For the Fourier cosine series, we extend the function f, we extend it to an even function. And here's the formula. The Fourier cosine series contains only the summation with the cosine terms, with the coefficient a0, an, as these formulas. For Fourier sine series, you only see the summation with sine terms, with the coefficient given by this formula. So let's do it for this one. We have a function defined for t between 0 and 3. We want to extend it to an odd or an even function and use the Fourier sine and cosine. So do the Fourier series for the odd or even function. And then the Fourier series at the end will contain only sine or cosine terms for the summation. Now let's do Fourier series, sine series. So we have the Fourier series of f is the one now contain only the summation with the sine term. Summation bn sine n pi t over L and from 1 to infinity. So in this case L is 3 in our case. So we define for t from 0 to 3. So L equal 3. Ft equal to summation bn, which we will find later, sine n pi t divided by 3 and from 1 to infinity. Ft. This is the sine series. Now we need to compute bn. Bn is computed as 2 over L, which I write the general formula first, integral from 0 to L. Ft sine n pi t divided by L dt. In our case, 2 over 3, 0 to 3, Ft sine n pi t divided by 3 dt. So this is a formula in our case because we have L equal to 3. You need to break this into two integrals because the function f we are given here is defined with two formulas. 2 over 3 outside. Inside you have from 0 to 2. Ft for t from 0 to 2 is equal to t. So t times sine of this dt. So this is on 0 to, and then you need 2 to 3. For t between 2 and 3 you have 1. Ft equal to 1. So 1 times sine of this. Now all we need to do is in this case compute integral by integration by part. In this case you can get the answer immediately. So you do the computation, you will get this. It's really big. 6 over n square pi square sine 2 pi n divided by 3 minus 2 over n pi. Inside you have minus 1 to the n cosine 2 n pi over 3. Yes, we need to do integral, compute. By computing, you get this. Compute it explicitly. You get this bn. So this is our bn. And plug in this formula, you get the Fourier sine series. Fourier sine series for f is given by this formula. where Bn equal to this formula. So now let me do one example. If they ask us compute B1, for example, what is B1? Then B1, you just do an example here. So B1 equal to, you plug in n equal to 1. B1 is 6 over 1 square pi square sine 2 pi over 3 2 over 1 pi minus 1 to the 1 cosine 2 pi over 3, and this is 6 over pi square. Sine of 2 pi over 3 is square root of 3 over 2. 2 over pi minus 1 cosine is minus 1 over 2. So we have 3 root 3 over pi square minus or plus 3 over pi. This is B1. That's an example of computing one coefficient in the Fourier sine series. The general formula is this. You do similarly, you can get the Fourier cosine series.